At 40,000 feet above Earth, there's a place so cold, so unforgiving, that even the air itself begins to vanish. This is the realm where modern airliners cruise, a place where temperatures can drop to minus 70 degrees Celsius. That's colder than any temperature ever recorded at the North Pole. Yet somehow, hundreds of airplanes slice through this frozen desert every single day. So what really happens when a jet soars into the coldest layers of our planet's sky? And what happens to the engines, the metal, and the people inside when the outside world could freeze steel solid in seconds? Let's step into the coldest flight ever. The air up there isn't just cold, it's thin. At 40,000 feet, the air pressure is less than a quarter of what it is at sea level. That means oxygen molecules are scarce, and the few that remain move sluggishly in the cold. The temperature can plummet to minus 70 degrees Celsius, sometimes even minus 80 degrees Celsius over polar routes or during winter jet streams. At those altitudes, the boundary between the troposphere and the stratosphere forms, and that's where airplanes live. But why go there in the first place? Because cold air is dense, and engines love dense air. When the air is cooler, the oxygen concentration per cubic meter is higher, meaning better combustion efficiency and less drag. In simple words, flying high and cold lets aircraft move faster, smoother, and cheaper. Still, there's a limit. Too cold, and things start breaking down. A commercial jet's engines are masterpieces of heat and precision. Inside, temperatures reach up to 1,500 degrees Celsius, literally hotter than molten lava. And yet, the outside of that same engine might be facing temperatures colder than Antarctica. This brutal contrast means every part of a jet engine must be engineered to expand, contract, and flex perfectly. A single metal blade in the turbine can be spinning at 10,000 revolutions per minute, experiencing both searing heat and freezing cold in seconds. If the design isn't flawless, the entire engine could tear itself apart. During extremely cold flights, especially over the poles, another challenge emerges: fuel freezing. Jet fuel isn't like gasoline. It's made to resist freezing, but even it has a limit. Jet A fuel used in most regions freezes around minus 40 degrees Celsius. But the type used for long-haul international flights, Jet A1, can resist up to minus 47 degrees Celsius. Now imagine flying through air that's colder than that. If the fuel in the wings begins to approach its freezing point, it thickens. That could clog fuel lines or block filters. To prevent disaster, sensors constantly monitor fuel temperature, and pilots can reroute the aircraft to warmer altitudes or increase speed to generate more friction heat. Sometimes, they even descend thousands of feet just to warm the wings by a few degrees. Speaking of wings, they too face the wrath of the cold. Every square inch of the aircraft is exposed to wind chill at nearly 900 kilometers per hour. At those speeds, ice doesn't just form, it can instantly build up, changing the shape of the wing and destroying lift. To fight this, airplanes are equipped with anti-ice systems that bleed hot air from the engines and channel it through the leading edges of the wings. The nose cone and engine inlets are heated too. Without these systems, an aircraft would literally freeze solid mid-flight. In the cockpit, however, you wouldn't know any of this is happening. Pilots sit in a calm, warm, climate-controlled bubble. Behind those thick windows, the temperature might be 22 degrees Celsius, perfectly comfortable, even though just a few centimeters away, the glass faces a frozen void of minus 70 degrees Celsius. Every inch of the fuselage is insulated like a thermos, and the air inside is pressurized and heated through air packs powered by the engines. The cabin's environment is kept roughly equal to what you'd feel on top of a 7,000 to 8,000 foot mountain. To the human body, it feels normal. But if that pressurization were to fail, the cold would take over instantly. At that altitude, exposed skin would freeze in seconds. Breathing unpressurized air would cause oxygen deprivation in less than a minute. That's why emergency oxygen masks are designed to deploy automatically, giving passengers enough breathable air while the pilots dive the aircraft to a safer altitude. The cold doesn't only challenge the plane. It reshapes the sky itself. At these temperatures, water vapor forms ice crystals instead of droplets, giving rise to the bright white contrails that trail behind jetliners. Those frozen streaks mark the paths of flights cutting through the most hostile region of our atmosphere. And sometimes, when sunlight hits just right, those contrails shimmer with a faint halo, the sky's reminder of the delicate balance between engineering and nature. But not every flight experiences such extreme cold. These conditions usually happen near the poles, or when aircraft fly above powerful jet streams in winter. For example, Flights from Asia to North America that arc over the Arctic Circle can encounter outside air temperatures below -70 degrees Celsius for hours at a time. Pilots monitor these with precision, not just for fuel freezing, but also for navigation and communications. Because at such latitudes, even magnetic compasses start to misbehave. There was once a Boeing 777 on a polar route that faced outside air colder than -76 degrees Celsius, one of the coldest readings ever recorded in flight. The pilots had to descend 4,000 feet and increase power just to warm the fuel. For those few minutes, they were flying through one of the most hostile environments any human craft has ever survived. And yet, everything worked, every pump, valve, wire, and sensor, like clockwork. It was a quiet demonstration of how far aviation engineering has come. The human body cannot survive there, but our machines can. Our technology has conquered a realm colder than any mountain, higher than any storm, and more lifeless than any desert. So, the next time you look out of a window seat and see frost sparkling on the edge of the wing, remember this. You're flying through an environment that could freeze steel and shatter glass, yet you sit comfortably, sipping coffee, while traveling faster than sound did in the early days of flight. That's the marvel of aviation. It's not just about defying gravity. It's about mastering the cold, the thin air, and the impossible. And at 40,000 feet, through air colder than the Arctic night, humanity keeps flying, one frozen mile at a time.